So in this problem, we're told that line K does not pass through the origin, and we're asked to evaluate these three statements to tell us whether we have enough information to say whether slope of K is negative or not. So we'll look at each statements one by one. The first one says that the x-intercept is twice the y-intercept. So we can do this in two different ways. One is graphically, and we can just draw this out, draw some examples. So for example, if the x-intercept is 4, 0, it has to be twice the y-intercept. So line could go like this, and yes, it does have a negative, and all of these pairs here, wherever the x-intercept is twice, they will all give us negative. But then if we go on the negative side, and that would be the same case, for example, minus 6, 0, which is twice, say, 0 minus 3. And so in all cases, we are going to get a negative slope. And anytime we consider a case like this, one is going to be negative, the other is positive. So I won't be able to satisfy this relationship. And same thing here. So that's one way to do it graphically. The other one is to use the general form of the equation of a line. B is the y-intercept, and x-intercept is the condition when we set y to be 0. So if I had to express the x-intercept in terms of the slope, which is m, and the y-intercept, I would compute the value of x, and I'm going to use this subscript to indicate that this is the value of x-intercept. So x-intercept would be minus b over m, and the condition we're given is that the x-intercept is twice the y-intercept. And we know b is not 0, and the condition was that it doesn't pass through the origin. So I can actually cross-multiply, it becomes 2mb, and divide both sides by b, because b is a non-zero number. And I get 1 here and 1 here. So I get 2m equal to minus 1, or the slope is minus half, so it is indeed negative. So A works. So you can take either approach. B says that the product of the x-intercept and y-intercept is positive. So again, we can either do it graphically, and that would mean, again, that they are both positive. So examples like these lines, both are positive, or they're both negative, like these. So in all cases, we find that the slope is indeed negative. So B also works. To do it algebraically using what we did earlier, equation of the line, slope is B, and or I should say, the slope is not B, this is the y-intercept. And then I have to multiply it by the x-intercept, and I computed the relationship. It's minus b over m, and we're given that this is greater than 0. This becomes minus b squared over m. And we know b squared is always positive, irrespective of what b is. And we have a negative here. And so for this relationship to hold true, m has to be negative. So again, same conclusion. So b also holds true. Now C gives us this condition that line K passes through these 2 points, A, B, and RS, and it tells us A minus R times B minus S is less than 0. So I'm going to write the slope using these 2 points. So it's the difference between the y coordinates, B minus S, divided by the difference between the x coordinates. So this is my slope, and I need to find out if I know the sign. So again, if I look at this identity and just visualize each to be a collective piece and think of it as the product of those two pieces is negative, then it can happen two ways. Either A minus R is positive, or B minus S is negative, or this is negative and this is positive. And under these circumstances, because these expressions come up in the slope, I have really two scenarios: negative divided by positive for the slope, or positive divided by negative. And in both cases, the slope, or this expression, will be negative. So C also works. So recap, A, B, and C, all three work.